Evaluate integral over C f bar dot dr bar by Stokes theorem, where f bar equals y square a plus x square j minus x plus z into k, where C is the boundary of the triangle with vertices 0, 0, 0, 1, 0, 0 and 1, 1, 0. Recall that Stokes theorem establishes relationship between line integral over C f bar dot dr and the surface integral double integral over S curl of f bar dot n into ds, provided the surface S is an open surface bounded by a closed curve C along which the vector function f bar acts, and n is the unit outward normal with respect to surface S. Here we have the closed boundary C will be the boundary of the triangle and the surface will be the interior of the triangular region. When you look at the vertices of the triangle, you notice one thing which is common to all the three coordinates, which is all the three vertices are having z values equal to 0, which means that this triangle is located in the xy plane. Since the required surface lies in the xy plane, we have the unit outward normal with respect to surface S will be the normal which is perpendicular to the xy plane, which is n equals k cap. If you wish to evaluate the RHS of the Stokes theorem, that is, if you wish to evaluate the surface integral, then you have double integral over S curl of f dot n into ds has to be evaluated. We have curl of f can be evaluated using this determinant, whose last row will be the component functions of the given vector function. By usual determinant evaluation, you will get curl of f as j plus 2 times x minus y into k. We have already evaluated that n cap, which is the unit outward normal with respect to surface S, will be the k cap unit normal. We have curl of f bar dot n can be evaluated as dot product between these two expressions. Since k dot k equals 1 and k dot j equals 0, we have curl of f dot n is obtained as 2 times x minus y. Now we have, by Stokes theorem, line integral can be equated to the surface integral. We have evaluated curl of f dot n equals 2 times x minus y. If we wish to perform the double integration such that integration with respect to y is performed first, then you have to consider a vertical strip inside this triangular region. When you draw a vertical line inside the triangular region, you have the upper portion of the vertical strip will touch the line y equals x, and the lower end of the vertical strip will touch the x-axis. Therefore, y varies from 0 to x. When you allow this vertical strip to move across the required triangular region, you have, when the vertical strip reaches this position, which is one of the vertices of the given triangle, then it becomes the point 0, 0, 0. From there it enlarges and enlarges as it moves across the required triangular region, and when it reaches this side AB, it becomes the largest vertical line. At that point we have x has the value x equals 1. Therefore, range of variation of x will be from 0 to 1. Thus we have this double integral can be evaluated using y varies from 0 to x, and after that x varies from 0 to 1. When we perform integration with respect to y, x will be treated as constant. After that, integration with respect to x is performed last. We get the double integral takes the value 1 by 3, which is equivalent to the line integral f bar dot dr.